So, as I said, I'm Troy Kershaw. I am at Twitter and you can follow me. My alias is @TroyKershaw. I also sell these t-shirts. So you can so just come and see me after the show and I will get them for you. So my talk is Stay Pure and Don't Become a Mutant. Specifically what we'll be talking about though is some functional paradigms that sort of some of the really simple core stuff that you will be doing in all your languages anyway, but F# makes it easy and it's sort of a slight change in focus. So we're looking at pure functions and immutability specifically. Okay, so can anyone tell me what makes a function pure? Yes?
You don't modify objects.
Sorry?
You don't modify objects.
Almost, not quite.
No side effects.
Similar. No side effects, yes.
Yeah, the same thing. Given the same input, always get the same output.
Yeah, that's right. So that's interesting that you mention not changing objects because in some ways you can change objects. So it's not a blanket, don't change stuff. That's the immutability bit that we'll get to later. So a pure function does not cause side effects or same arguments. So same arguments. See, I consider these people here, they're the arguments, and they produce the same output. And also, we don't change stuff. It's, and that's the idea. So, as you've said, well worded, it's almost the same as I've got here. So, what we're going to do is to sort of work out whether a function is pure or not. We're going to play a game based on the world famous hot or not. But this one is going to be called pure or impure. So I'm going to show you some code. We're going to talk about some F# syntax as well. It's pretty easy stuff. So if you have seen it before, you'll go, I understand it. If you haven't, it's a pretty good introduction. So I'll show you a function. We'll talk about it, and then as a group, you can decide if it's pure or impure. So this is our first one. So let add AB equals A plus B. This is a function in F#. Let is similar to var in C#, as in it allows you to create a value, but it also allows you to create a function, so it's not limited to that. So right here we are creating a function called add. It takes two arguments, A and B, and it returns the addition of those two values. A few things to note, as was discussed earlier when we were talking, there are no type declarations. Like, we're not telling F# what A is it an int, a float, or a string, or whatever. All those things can be added, nor are we saying it for B either. And we don't have a return statement. So it will just, whatever the last thing we do is, that's what exits the function. So that's it. So I'll stop fiddling now. So let add AB equals A plus B. Any questions on this one? How it fits, what it does? It adds two numbers together. We know it's int because that's the default thing. So A is an int, B is an int, it's an int. Is it pure?
Yes.
It is. Now, we'll see. It is. It's pure. Now, why is it pure?
What goes in doesn't change.
You get the same result.
Like A still stays A and B still B.
That's it. If I put 10 in here and 20 in here, the result's always going to be 30. Doesn't matter when I put 10 or 20 in. Whatever I put in is always the same. All right, we'll move on. Next one. F# has access to all .NET stuff. It will do it. So instead of using system, we just say open system. It's the only difference. And then we can access great things like datetime.now. So we have created a function called today. It takes an argument of unit. We call that unit. So you can sort of think about it like you would, like you call it with brackets in C#, but it's not the same. It's actually an argument, those two brackets, but they mean nothing. So it's just, I don't know if that, does that make sense?
Yeah.
You're just saying it's a function, but we don't want to take anything. If I got rid of that, that would just be a value. Because we would just say let today equals datetime.now. We would set datetime.now to today, and then that would be it. It'd just be a value. But by adding in the two parentheses, we're passing in a unit. Okay, and then every time we call today, we get datetime.now. Is it pure?
No.
Why isn't it pure?
Because
You're right.
data now changes.
Yeah. Every time we call it, it's going to be different. So, or well, potentially. I'm not sure. I'm sure it wraps around at some point. We do have a datetime.max. So, yeah, so it is impure, and the answer there was correct. All right. Here is one. Let who is happy with the argument name, and then I do this great thing. So printf n is similar to console.writeline with a string format. So it's very close to sort of C++ looking stuff, where %s is, print a string. That's it. So all we're doing is saying, write to the console. It's a nice shorthand of saying, instead of saying console.writeline. And we pass in all of our arguments. So name will go in where the %s is. Is this pure or impure?
It's pure.
Impure.
Okay.
Impure.
So we've got it is pure or it isn't. Let's see.
Or
Impure. Why? Let's talk about it. So, who is happy? Name. So when I put in my name Troy, I'm always going to get back Troy is happy all the time. So it satisfies the first part of it, which is it has to always give the same result. But why is it not pure?
because it doesn't return anything.
Because printing out is a side effect.
That's right. So you can have a pure function that doesn't return anything, that is fine. But here we've got a perfect answer, which is it has a side effect. The side effect is,
Console.
writes to the console. So it's actually doing something and manipulating something outside the function.
Who needs a program which does nothing?
What's that, sorry?
Every program has side effect. It does something, right? So it writes something, creates a file, it sends something. So every program has side effect in some way, sort of way.
That add function didn't have a side effect.
Yeah, that's right. So the add function,
Every useful
and we will get to that, is that what we're talking about are like what pure is, but we will talk about the times a little bit when you can be impure. And that's
I
okay.
guess the point is that's not a bad thing. Having impure functions is not a bad thing. I mean, you can use it. I mean, if you need it, you do it. But
Confers,
you can.
That's it. All right, next one. This one's called let. I'm changing stuff. You may note that we have an apostrophe in there. That's totally fine in F#. In fact, in some instances, you can have spaces. And it's good fun. Particularly when I use spaces all the time when I'm writing unit tests, because it's great to say, given, something that a user does, when something happens, then you can just write out your unit tests in full with spaces, and then your test runner comes back and it's just lovely. Like, it's just really good to read. Don't have to read camel tests. Okay, so we can have apostrophes, but essentially we've got I'm changing stuff, taking X, and then we get a little bit more complex code. So up until now, we have just been saying, in fact, I don't think we've had a value, set a value. So let b equals 20 is us setting a value. It's creating a value. We call it a value over a variable because it doesn't change. It is just a value. It is immutable by default, and we'll talk about immutability a little bit later. So b is 20, and it will always be 20. However, a, we don't want to always be 10, so we have to tell it that we want it to change. So that's where the mutable bit comes in. So we're saying let mutable A equals 10, let B equals 20, and then we have the mutate operator here, and we're saying, well, let A equals A times B times X, and then we return A. Are there any questions on that? What we're doing here?
So that less than equals is an assignment.
Yeah, that's an assignment.
Yeah.
Absolutely. So that's right. So if I had put equals there, it would have given me a compile error. Yeah. Yeah. So yeah. So that's it. So it's essentially you have to be really explicit with your assigning things in F#, but you can do it. You are allowed to do it. Is that pure or impure?
Pure.
Pure.
So was that consensus on pure?
Is that impure?
Sorry?
Impure.
Impure. We've got an
Changes
impure.
that, but it doesn't escape the function.
That's right. It is, in fact, pure for that very reason. It doesn't escape the function. So we've got mutability and change inside it, but we're not changing anything outside, so it is pure. Okay. So there are a lot of benefits to writing code that doesn't change things outside its own function, method, scope. Can anyone give me some ideas? What might be some benefits?
I can give you one. Is that if you look at something in a debugger, whatever set it is always higher on the stack. Can't be anywhere else.
Yep. Okay, great. Anyone else?
Cache the result.
What's that, sorry?
Cache the result.
Yes, you can cache the result because you know it's not going to change. In fact, if you do care to look into that, that's called memoization with a Z. And it's a really cool practice that you can employ if you go down this route. So great, good answer. Anyone else? A really common one is parallelization, if I struggle on that word. But essentially, because things are not changing, you can trust that function and you can run them side by side. You're not going to have an issue with it trying to, access the same file at the same time because they're not allowed to do that. They're not allowed to change anything that's outside their own scope. They're pure. So that is, if you Google it, pure functions, benefits, you'll probably find that on people's favorite wish list. I actually don't write a lot of parallel code. I do it as much as possible. I do async, of course, but it's not the same as having things just pumping down in parallel. So that is not a huge benefit for me. Although for me, testing is. It's just you can really trust your functions. Like you can run your test runner. You can trust it. Values that come back, fantastic and perfect. But the biggest issue I found in changing from C# to F# was the fewer bugs. That's just it. I just had less bugs because I'm a bad coder, I assume, and I put lots of bugs into my applications, and F# stops me at the syntax and compile level and makes me rethink the way I approach things.
I find, because I do a lot of just maintaining code, I'm always forever following the tracing through the code, and here's an object that will get passed into a method or a function, and you don't know what's been changed inside or whether it is being changed or something like that. And that's because of the fact that, we don't know if there's any side effects or not. We have to go dig into the implementation.
Yeah, that's right.
Details.
And it might work fine while you're writing it, and you go, oh, I know exactly what that does. 6 months' time, I guarantee you will not have a clue what the code you're writing does. In my case, it can be sometimes a week or 2 weeks, and I have no idea what is going on. So that pretty much is what a pure function is and their benefits. But we are going to take it a step further, and it was mentioned before. One other benefit that is similar to this, and it's a functional way of thinking, is mutation. So that is changing things at any point. And we looked at that a little bit in code. And so one does not simply mutate a data structure. So we're going to look at some more code a little bit. In fact, this is the same code for the first instance where we said, We mutated that variable. We said we want this variable to change. We didn't create it as a value. Now looking at this, we could clearly have made that immutable. In this instance, it's very easy. We just don't assign it to A. We just return the multiplication. Very simple, and easy to avoid bugs. Now, so in in F sharp, as we said, it's always immutable by default. So let B equals 20, immutable by default. We have to set mutable on variables if we want to change them. Now C sharp also has a mutable operator, or keyword, I should say. Does anyone know what it is? Oh, that is the immutable one. The immutable one is var. Everyone's using this. You get this by default. You are changing things or have the potential for things to change. And then just to make matters worse is that when you pass your var into a method, it gets passed by ref, which means that whatever you pass it to can change it. And it's a big nightmare. And that's where your many bugs come in. And as was mentioned before, you do actually have an immutable one. So it's mutable by default, but you can make it immutable, and you just add read only to the start, but only for values declared at the class level. So you do have a slight limitation there, but if you are working in C# and have to continue to, you can still apply all of this stuff because you've got a fair bit of flexibility there. Okay, so the largest problem I have with lots of things changing, as we discussed, everything's passed by ref in C#, and so we end up with lots of bugs this time. We get a few bugs, or one bug with pure functions. This case we get lots of bugs. And am I exaggerating? I'll tell you a love story that will hopefully show the dangers of mutation. So this is Fry. This is Leela. Is anyone familiar with Fry and Leela? Okay, fantastic. Fry is in love with Leela. Leela is a mutant though. Fry is human. Leela is a mutant. It is a secret on planet Earth that Leela is a mutant, because if everyone knew that she was a mutant, she would be forced to live below the surface in the sewers. And no one wants that. But of course at this dinner party, Fry lets slip that Leela is a mutant, and she gets carted off by the police and sent to live down under the surface in the sewers. Now, Fry feels really bad about this. He still loves Leela. Leela's not too happy with him, as is expected. And he goes and decides that the only way he can show true empathy and understanding for what Leela is going through is if he himself becomes a mutant. So he gets ready and he's going to step into this toxic lake that will instantly mutate him. We can see Leela saying, no, don't do it over here. Doesn't want him to go through it, but he feels he needs to. So he jumps in the lake. Leela tries to come to the rescue, pulls him out, and I went one slide too far. He becomes a hideous mutant. And that's what we've got. So what we have here is Fry started to associate with a mutant. Things got way out of hand. He did nothing wrong, really, and he has become an even more hideous mutant than just one-eyed Leela. That is the sort of danger that we play with when we start mutating variables, or we play with someone else's mutated variables that happen to be coming into our thing. It just escalates and gets really bad, and that's where we end up with loads and loads of bugs. So, as you've already seen in my next slide, we can see SpongeBob saying it's okay to sometimes mutate variables or not be pure all of the time. We've seen that printf or console.writeline is not pure, that it causes side effects, but is writing to the console a bad thing? No. It's not. it's fine. We need to do it. We need to sort of give input to users or output or feedback or something to users through the console. What are some other examples?
UIs.
Sorry?
A UI.
UI is a classic example. When you write a UI in F#, you may start to go, I wish I just did it in C#. And I've had that experience. It's usually worth, pushing on though. You just get used to typing mutable a lot.
The actual underlying UI is doing messages.
Yeah,
So it's actually the wrappers for C#
yeah.
that make it look mutable.
There you go. So UI is a great example. Is there anything else? I'm sure everyone does this. I've got an example here that I'm going to show. I/O? Yeah, that's exactly right. And what I've got here as my example is actually logging. We log all the time. Logging is not pure, and we're causing a side effect, but we still need to do it. So these are things that it's okay sometimes to do it, to mutate and to be pure, but we mutate like in a UI because we have to. There is really no other way. Although, go to the Haskell user group and they will tell you. Otherwise, they've got a fancy solution that I don't quite understand. But that's why I stick with F# because of mutable key. And that's pretty much it. So here is an example of a function that we've looked at before. It's slightly modified so that we can log the result. But we are saying let add AB. Result becomes the addition of those two ints. We log the result. Here is just our sort of sprintf is will do the same as a printf. It's like string format. It's the same thing. So it is just going to return that in one nice string. So it's going to log that string for me, return the result. So everything about this is pure except the log thing. So if we get rid of that, it's a pure function. And we're happy. So what I like to do, or what I try to do, is keep my functions that I might use a lot or that I'm going to test as pure as possible or completely pure, and just pull this out and put it somewhere else. Here is an example. We could just call add 1020 and assign it to the value added, and then call the log. So we just pull the impure or mutable stuff out and put it in a nice place where you can keep an eye on it, and you can still go and test your other stuff. Okay, now the problem with this is not anything to do with pure, impure or not, but it's really ugly to read. And here's just a little side note on something cool in F#, but it's probably for a topic of another day. But this is the wrong way round, and we write this code all the time in imperative or object-oriented languages. We write things the wrong way around, and it confuses our brains. So I'm saying log, but that's the last thing I want to do. And then the next thing I'm doing is saying, well, turn that into a string, but that's the second last thing I want to do, and added here is the first thing I want to do. F# allows you to flip that around by using the pipe operator. So in this case, we have the pipe forward operator, which allows us to, as I said, just invert the way we do things. So we add 1020, we send that result to the string format here, sprintf, and then we send that result to log, and we're happy. It's easy to read, everyone's happy, we've written our code, it's not going to have any bugs in it because it's F#, and that's it, we're good.
Another huge advantage of it is the type inference works forwards.
Yes.
And so your type inference will work that way, but not the other way.
Yeah. And it's great. If this looks confusing, go and write some code, and I guarantee in 5 minutes of actually doing it yourself, it'll just click. That's what, the first time I saw that, I just thought, what is going on? So go to tryfsharp.org, and you can do it in the browser, and just find the thing on the pipe forward operator, and you'll be laughing, and you'll never want to use C# again because you'll see backwards. So Okay, so that's really good, and sometimes it is great to use immutable stuff, but I look at it as a bit of a white lie. We say white lies are okay, we're just, we've got good intentions, and it's noble, we're not hurting people's feelings by telling white lies, but our nose still grows. And let me tell you, I have a fairly large nose. It's not from my lies, I hope, but it's awkward to have, especially drinking. If you get small glasses, it gets caught on your nose. You do not want to go down that route. So Pinocchio lies too much. He ends up in prison with a long nose that sticks out of the bars, and I'm sure he keeps lying and he can't turn around in his cell, and it's all really awkward. So you want to just really think about what you are actually allowing to be mutable or allowing to be impure. It's okay to do it, but just think about it. It's, don't let it spiral out of control. Don't say, this is the easy way, this is how I've always done it. Just take that step and try to make things pure. So yeah, just to summarize, or just to finish off, in case anyone's wondering, what happened to Fry? He revolted, he led the mutants out, they turned the sewage back up and it flooded the city, the mayor got upset, and so they protested. They're all here saying, we want mutant rights. Leela finally fell back in love with Fry, and she went to give him a kiss, and it turns out that he wasn't actually a mutant, he just stepped into a mutant's mouth, and he's all okay. So using mutation is sometimes okay, but not always. Fry's case, he was very lucky to get out of that. You may not be so lucky to just step in another mutant's mouth when you do it. So thank you very much. If there's one thing I want you to take out of this, it's just rethink the way you're doing things. So if something is, if you're writing some code, just think, can I do this using pure functions or methods? You can, whatever language you're in, it's just a principle. Can you do it? Can you do it without mutating stuff? Because it will benefit you in the long run. Thank you. Any questions?